Hello, welcome to this tutorial on Ohm's law, power and efficiency 1. So, first of all, what is Ohm's law? Well, if you have a component and it's got a characteristic of VI and it's plotted like so, where it's straight line. That means for whatever current you put in, the voltage is going to increase with it. So therefore, R is always equal to V over I. You will get the same resistance at different current. Okay, so it means that this component is an ohmic. It's got an ohmic resistance. Okay, so when they say then therefore Y is a diode is a non-ohmic device, well, if it's a non-ohmic device, then it would not have a straight line. Well, if you refer back, a diode symbol looks like this. Okay, so if the current it goes into this direction, this is called the forward bias. That means the current will travel a lot across this diode in this direction. Whereas if you have current on the other way, so this is then there will be no current through. That's what the diode is used for. It's not allowing current through if it's running on a reverse bias. Okay, and this will be more clear when you work on the chapter 19. Where it discusses diode, how you use diode to make a rectifier circuit. Okay, so in the meantime, so what does a VI characteristics of a diode looks like? Well, we tend to do IV, so that's why it's called IV characteristics. So IV, it doesn't matter. Okay, so long the diode characteristics does not follow a straight line rule. So it looks like this. So it looks like it's straight line, but actually it's go flat across and go through 0 here, and then it comes across like that, and then reverse bias. Okay, so the diodes tends to work what we call the cutoff voltage. Okay, along this straight line, this is where it's going to start working, because then there's above that voltage the current increases. Okay, so but in general the resistance is not constant. So it might be constant along here. Okay, but it's not quite a straight line. It might look like a straight line, but throughout the whole of the curve of the characteristics, the resistance is different. Okay, so therefore R is not equal to V over I. So that's the reason. Okay, so you might want to write that in words. So I might write in the exam, although it goes through the origin, the resistance, V over I of the diode is varies with between voltage and current. So R is not equal to V over I, therefore it does not obey Ohm's law. Okay, so it does not obey Ohm's law. It does not obey Ohm's law. So for this question, I think you'll get marks if you sketch the IV, characteristics of the diode using IV on the curve axis. Okay, so that's that one. And now question 2. Power tool. Maybe perhaps it's a drill, etc. So 110 volts is being supply, and it's got a power rating of 1.5 kilovolts. So you got power, you got voltage, and you're asked to work out current. So P is equal to V times I. So you now need to find I, so therefore current is equal to P over V. So the power is 1.5 times 10 to the power 3, which is kilo, and then therefore it divided by 110. Put that in the calculator. That should give you the current. Okay, so and so that comes to 13.64 amp. Now, because of this, so you it's not normally used in a at home, because usually in the wall socket is 13 amps. So this actually draw more than 30 amps. So what you might find is that if you do operate from the mains, then you might get a short circuit. However, the fuse will go, but however it's running at 110 volt anyway, so you can't plug it into the socket because it's 230 volts in the UK. Okay, so just some, it's good to always discuss your answer and think about what this answer means. Okay, thank you.